How many of you are in the ops business? Okay, I can see some hands. How many of you are in the development space? All right. Almost like 50-50. Cool. And the last question, how many of you are already familiar with Ansible? Okay, it's good. All right, so let's get started. So our company, it's called Streambright. We just got started like 2 weeks ago. We are a software consultancy in the big data space, and the website is coming soon. I am the CTO, and you have my Twitter handle there. And I used to work as a systems engineer for various companies like, Amazon, Riot Games. I don't know how many of you are familiar with Riot Games. It's a company that makes Leagues of Legends. You know probably that game. And I used to also work for IBM. So this talk is about like automation. And first we are going to define the problem. And then I'm going to tell you some stories and presenting a solution that we like at Streambright. And I'm going to keep it high level because we have limited time, so there is no time for deep diving into code. But I have at least 2 slides with code, so it's going to be enough. I'm going to be talking like quietly, so I don't wake you up after lunch. All right. So what does automation really mean, and microservices really mean? This is a really good question, and I'm going to be talking about like previous experience, a little bit of history, problems and solution, and then we have 5 minutes questions. And this is going to be it. So what does automation really mean? Because this is a really crucial question in this space. So automation is basically an automated, non-manual way of deploying changes to your infrastructure. This means like code and configuration as well. Mostly it's about like applications, but some companies use automation for equipment like Cisco switches and operating systems as well. And this requires some minimal human interaction. Upgrading and downgrading should be trivial. And if you can do it like the way that there is no service downtime, that's the best. But sometimes you cannot do that. So if you are changing something in the core router of your company, then is necessary an outage. And this means also repeatable, short development cycles, reliable changes, and low impact on the service that you are changing. There's a really good book in this area. It's called Continuous Delivery. How many of you are familiar with this book? I see some hands. Good. If you are not familiar with this book, then you should definitely read it. It's a really useful information, and it gives you like knowledge that you can actually apply immediately to your company or to your problems. So smaller companies, usually start with deployment automation. They have like a service and they just want to automate that. It's really simple, and most of the companies also like to apply this automation to the operating system changes. So when you have like let's say SSH config changes or something like that, then you like that. You like to automate that because the less human interaction you have, the less errors you make, and it's much better. And bigger companies like to include network equipment. So, for example, in Amazon, all the switches are automatically configured. So when you power up a switch at the first time, it's going to go to a service. It's going to report its neighbors, and it's going to get back a configuration file. It's going to apply that configuration file, and it's going to come back online without any human interaction. This is kind of the highest level of automation, and you don't have any human interaction at all. And some people like to take it to the next level, like this guy. If you're not familiar with this, there was an article about it, and it's really good. He automated the hangover, and this is the code. So whenever he gets a hangover, he basically chooses a random sample from that list, and he writes a nice message to his boss saying, "Sorry, I'm not going to show up at work. This is the reason." And he's going to send it to his boss, handler. I don't know what he's using, Twilio actually. Yeah, so that's like a little bit extreme, but just to give you an indication that you can do that too. All right. So microservices. it's a buzzword, and lots of presenters have these microservices in the title. So what is microservices at all? So microservices is basically the Hacker News name for service-oriented architecture. Hacker News, those guys like to reinvent the wheel since 2002, and they keep renaming things. So microservices came from there. It's actually a service-oriented architecture. It's a pretty old concept. It's at least 10 years old. Amazon and Google use it a lot. Basically, entire Google runs on microservices or service-oriented architecture. Amazon, same thing. If you go to Amazon.com, you are going to touch probably 2,000 services. So the single page rendering includes 2,000 services. So this is, you get a feel of it, like how many services you can, use for your website. So services are usually unassociated, loosely coupled units, and units of the functionality that are self-contained. That's really important, that you have to kind of use it the way that it's self-contained, it doesn't depend on anything else. And if you actually talk to another service, then you have to handle the outage of that service. That's a really important property. And services communicate usually through a very well-defined API. Most of the companies like to use REST, and Google uses protobuf and other protocols, but basically this is it, like a simple API. So there are some practical implications of using microservices. You can achieve higher parallelism than with monolithic services. The impact of your change is smaller. So imagine that if you have like 2,000 services and you change one and you cause an outage, the damage is much less than you have like 2 services and then you take down 50% of that. So this is one reason why microservices are good. Common functionality usually lives in libraries. So if you have like an HTTP library, then you can put it in a library and then just keep reusing that same library across your microservices. And this is a good way of like abstracting your code. And it also means that you have high reuse of code across the similar services. So if you have like 2 HTTP services, then it's probably using the same library. All right, so what could possibly go wrong with this? Well, there are lots of things that can go wrong. I'm just going to give you like a rundown what usually goes wrong. And usually you have like missing or incorrect dependencies. That's a really common use case, because when you're developing something on your laptop and you add a new dependency, and then you build a new jar file, for example, and then you send it to production. Well, your dependencies didn't go with the jar file, so there is your problem. Missing or incorrect configuration files. That's also a pretty good example and a pretty common case. Sometimes, people forget to include the new configuration values in the configuration files, and or maybe they use like configuration from the QA environment or something like that. And you can also have like incorrect environment settings. So lots of Java developers like to use environment variables in their code. So it's kind of an implicit configuration because it just lives in the environment settings, and it doesn't get copied across services. So whenever they deploy something, then they forget to update the environment settings, and this is how you can end up with a broken service. And there is a very special 4th case, incorrect state. It's kind of not obvious like what incorrect state means, so I'm gonna talk about that a little bit. So I have 2 examples for the incorrect state. So let's say you had like a previous release and you left a file just lurking around on the server, and the new deployment happens. It doesn't clean up that previous file, so it's still there. And you can also have like certain cases when some part of your deployment fails, but it fails silently, so you are not aware of it, and just it's not visible to you. So some people might ask, is this that serious? Do you really need to care about these problems? Well, according to Knight Capital, who lost $465 million in a trading system due to a software bug. So what happened? They were trying to deploy new code. And here's the official postmortem. So, first of all, upon deployment. So this $465 million outage happened upon a deployment. They had unused code sitting on their server, and it was deployed there many years earlier. This is the official postmortem, because if you're a trading company, you have to put the postmortem, you have to send it to the US government to justify sort of your loss. And so this happened. So they had like a test software that was doing like kind of test transactions, and they forgot about that and they just left it on the server. And they deployed new code that had a switch that was used in the new code and in the old code as well. And the deployment system thought, oh, you are talking about the previous system, so it just silently switched to the old system. And they sent, I don't know, like 1 million transactions through that old code, and it's supposed to be a test, and it wasn't. So they went out of business. This was the last, this postmortem, the last thing from them, because they went out of business. So I think it's pretty important, if you ask me. And okay, so some of my experiences. This is less severe, obviously. So mostly what I see, because I work in the Java, sort of space, so we have mostly missing jar files. It's simply the developer just, adds a new piece of code, gets compiled, Maven takes care of that, and this is how you end up with missing jar files. And then sometimes you can also see this like QA configuration after a deployment sitting on your server instead of the production configuration. So you accidentally talk to the QA database instead of talking to the production database. That's actually happened, not even a single time with several companies who I worked for. So this is like a little bit like elaborating on the jar file thing. So the developer cycle, it's not automated. So the developer guy just adds a Maven dependency on for the project, runs the build, Maven takes care of the dependencies, jar gets built, sent to the servers, dependencies are not there. Oops, fail. How could we avoid this? Like this is the $1 million question. Or in the case, it's $465 million question. So having automated build systems, that helps a lot. So if you build these jar files, on an automated way, then it's much better. Actually, you can avoid these jar file problems. And using the same exec binary running on the dev laptop, on the QA server and the production server, that would be really nice. You can't really do that with only jar files, because the dependencies are kind of implicit, and then you don't have control over that. Somebody can just put a new jar file to your production environment, and it's not binary compatible with your dev setup. And this would solve half of the problems the missing jar file. And I'm going to talk only about that because time is very limited. The configuration part, I'm just going to mention the solution. So if you are having problem with the configuration files, the best way is to put it in a configuration service. And anytime when you deploy, you pull down the current configuration from that service. And you can use anything. There are lots of projects in the open source space taking care of your configuration. I also like to use just Amazon S3 and put up the configuration in JSON files, and that's pretty easy way. And it's pretty reliable, and then you have like sort of repeatable deployments, and that's good. But there is a better way of doing all of this. What's that? Containerization. So if you build a container on your laptop and you promote that all the way through the production system, that's a really good way of taking care of this problem, right? Because if the exact same container is running everywhere, then that's it. That's what you want to do. So how many of you are familiar with containerization as the concept? Lots of you. Okay, cool. All right. So this is basically what containerization means. It's an operating system level virtualization, where basically your application is running in a virtual environment. And there's a little bit of history for this. So chroot got introduced in 1980 in San Francisco. The BSD guys were probably high, and they were like thinking about like how to run an untrusted software on a server. What untrusted means? Oh, it didn't get written by the ops guys. That's untrusted. That's a definition of untrusted. And you know, over time it got developed. Like previously introduced jails in 2000, Solaris introduced zones in 2004, and then the Linux guys followed up with LXC. That's mostly developed by Google around like 2008. I think Google probably had it for a while before they released that. And in 2013, Docker got introduced. And in 2014, it reached Hacker News, and it changed the game. Docker became the de facto standard for the hipster stack. So if you're running any Go or anything like that, you know, like your stack includes these things, then you are on a hipster stack, and you need Docker. That's how it is. All right, on the serious note. Let's move over to talk about a little bit of Ansible. As many of you are already familiar with it, I just would like to reiterate the Wikipedia definition of Ansible. It's a free software platform for configuring and managing computers. It combines multi-node software deployment and ad hoc task execution and configuration management. So it actually does a lot. It takes care of your software deployments, that's really important, and it also takes care of your configuration management. And I think this is a really good solution. So let's talk a little bit about like why Ansible at all. So I have lots of experience with like Amazon internal tools, you know, that I can't talk about really, but also Chef, Puppet, and finally Ansible. So we used a lot of Chef at Riot Games, and we had lots of problems with it. First of all, it requires, you know, at the time it required a running service on all of the managed nodes, and it was non-deterministic. The Chef runs were never deterministic. It could always like fail with the most bizarre, you know, error messages that you couldn't really make any sense. And so this is the reason why I don't really like it. It does the job, so you know, if you are using it, it's okay. And Puppet, I don't know, Puppet is good, but I think you can go a little bit simpler than Puppet, and I think it's Ansible. So Ansible is way less complex and much easier to debug than Chef. So debugging Chef, it's almost impossible. All of the message passing between the server and the client is encrypted. So you actually need to put a debugger in the client code base. And when you call into the Chef server, then you know you jump into the debugger, and this was the easiest way how we could debug the Chef runs. This is definitely not the case with Ansible. And Ansible uses only YAML files, and that's it. Like it basically has a bunch of YAML files, and you can put your configuration and deployment task into those YAML files, and it's super easy to debug. Like you just pass the -v flag to the execution, and then suddenly you get back really useful information about what's happening on your managed nodes. And it's much easy to, it's super easy to reason about. If you show a YAML file to any ops guy or any developer peers of yours, and it's really easy to reason about. And it's really important in software development that you can reason about your code. You can reason about what you are doing. That's kind of important, at least to me. It's important. So Ansible organizes your content in playbooks, and playbooks refer to roles, and roles have tasks. So this is super simple. That's like really easy concept. Everybody can conceptualize it really well. Even you can show it to your managers, and they are, yeah, it kind of makes sense. So dependency management also easy because it's very lean. You cannot really build like huge chains of dependencies, in Ansible. You can probably do it, but I wouldn't recommend it. If you keep your dependency kind of lean and just couple of level deep, then you're gonna have a better time. And extending the original functionality is also very easy because you just need to write a little bit of Python, and there's very little what you have to actually understand about the execution. And for this reason, I also prefer Ansible over the other things. And the best part of Ansible, it only requires SSH access to your managed boxes and Python. That's it. If you have Python, if you have SSH access, then you can do it. And that's also a big win. There's no service running on your managed nodes. So imagine if you have, like, let's say, Chef running on your nodes, and there is a bug in Chef, and it has a memory leak. You can accidentally take down the entire service with your configuration management system, and this can never happen with Ansible because there is no process running over the time. So this is pretty good. And I'm going to show you like 2 slides. One is about like a playbook without using, or actually it's a role without using Docker, and then the next example is going to be with Docker. So this is the first example. It couldn't be easier. Like, it has a name, it has a task, what it's gonna do. It's gonna install Ambari agent, and then it's gonna just make sure that the state is installed. So let's say you don't have Ambari agent on the server, then it's gonna install it. If it's already installed, it's gonna skip. And there is obviously like sudo needed for the RPM execution. So you can just call in like saying sudo yes, that's it. These 3 lines of code, and there is very little. It's very little space for errors. Like you can look at it and it makes sense, super easy, and it's obvious. If you have a problem, it's immediately obvious like what your problem is. So this one assumes that your code lives in an RPM package, and that the repository is configured on your server. That's it. If you want to extend this, and you can make sure that the repository is already there, obviously, and you can also just install that if it's not present. All right. So this one is Ansible example with Docker. It's pretty similar to the previous example. It just, instead of having an RPM or YAM, whatever module, you're just going to use the Docker module in this case. You have a service, you have an image, and that's it. You have a state reloaded. Instead of like state installed, you have state reloaded. So in both cases, you are managing state of a service, or a package. In this case, it's a service actually. So this is why the state is reloaded. But it's pretty similar to the previous example, and I think it's big. Like this one, this is pretty lean, and it's really easy to reason about. So this is why we like Ansible. If you want to get started with Ansible and you are working in the big data space, in my previous job we created this repository. It's called Ansible Big Data. It has lots of examples of like how to automate services like Hadoop. It's like a pretty complex service, and it requires lots of different roles. Or Kafka that also has like maybe 2 different roles in the playbook or in the role, and it has a bunch of other. I think it has like maybe 15 different services. So if you want to get started and you didn't have a chance, to learn Ansible, and also if you are in the big data space, then I highly recommend this repository. You can send us pull requests if you found any bugs. So I think this is it. I'm going to recap a little bit like what we were talking about here. Luckily, my friends created this, so this is the recap of what we were talking about. So let's just install some Docker on all of your servers, and that's it. And now we are going to move over to the question sections. So, do you have any questions? Yes. I don't know if I should hand you over the microphone, or you have a...
I'll speak loud. I'll assume that you know the term, but what do you think of immutable infrastructure? So, infrastructure where you're not making any changes, and compared to using Ansible or anything else.
Right. So I'm just going to reiterate the question. So, what do you think about like immutable infrastructure? So, immutable infrastructure is a good idea. It's a great concept. But if you can show me a single company that doesn't require a change in their infrastructure, then it's a pretty good idea in that case. If you have companies that require lots of deployments, lots of changes in the infrastructure, lots of updates, because the developers are developing new software and it has to be deployed to your infrastructure, then then you have to manage state and you have to manage the changes. And if you manage state and if you manage these changes, then you have to use some sort of solution for that. So I guess Ansible is a good answer to that, but also the other tools. I don't know if this answers your question.
We can talk about it later.
Okay, cool. Anybody else? No more questions? There you go.
Do you consider
Yeah, I got warned that you are a salt guy, so I wasn't preparing for this question. Actually, I don't know salt. I think it requires a service running on your managed node. Is this true?
I'm not that salt.
Okay. All right. You know what? Maybe next time when I do a presentation, I'm going to be talking about salt. I don't know. I seriously don't know it, so I just leave this question open. But if anybody else can answer this question, then is there anybody who's using salt? No, nobody. It's pretty new. Did you read it on Hacker News? Okay. Anybody else? No more questions? All right, I think we don't have any more questions. Thank you very much for your time, and see you next time.